Hi students, now we are going to derive the expressions for Cp, Cv and gamma for a non-linear triatomic molecule. So non-linear triatomic molecule, for example water molecule we can take, okay. So in this case we have not determined the temperature here, we have not specified, because for both normal as well as high temperature, irrespective of the temperature, we are going to discuss this. Now, the average kinetic energy per degree of freedom is as usual half kT for any molecule, is it not? For degree of freedom it is half kT. And here number of degrees of freedom for a non-linear triatomic molecule is equal to 6. So in what way it is 6? 3 due to the translatory motion and 3 due to the rotational motion. So we have taken for a linear triatomic molecule equal to 5, is it not, at normal temperature, and at high temperature it is 7. But here all the 3 rotations along the x, y and z axis are to be considered, and at any temperature the vibrational motion of the molecules they are very complicated to study. Therefore we are considering only the translatory degrees of freedom and rotational degrees of freedom. So since it has 3 translatory and 3 rotational degrees of freedom, the total number of degrees of freedom of one molecule is equal to 6. Therefore average kinetic energy per molecule is 6 times half kT. So that is equal to 3 kT. Now the average kinetic energy for 1 mole. Naturally for 1 mole we have to multiply this 3 kT by the Avogadro number Na, is it not? So epsilon equal to Na into 3 kT, that is 3 into Na into K into T, but this product Avogadro number into Boltzmann constant is also equal to the gas constant R. Therefore epsilon equal to 3 RT is the first equation. Then as usual the specific heat capacity at constant volume Cv is the derivative, the first derivative of epsilon, that is du by dt. So this is d by dt of 3 RT, and 3R is a constant, d by dt of t is equal to 1. Therefore Cv is equal to 3R. This is our equation 2. Then from Mayer's relation, Cp minus Cv equal to R, Cp equal to Cv plus R, 3R plus R is equal to 4R. Therefore what is Cp equal to 4R? Then as usual, how do you determine the adiabatic exponent gamma equal to? It is the ratio of Cp and Cv. So gamma equal to Cp by Cv equal to 4R divided by 3R. R get cancelled and it is equal to 4 by 3. 4 by 3 is equal to 1.33. So the final equation number 4 is what? Gamma equal to 1.33. So now in general from the law of equipartition of energy, whether it is monatomic, diatomic or triatomic, linear or non-linear, the average kinetic energy for 1 degree of freedom is half kT. This is the first point you have to observe here. Then for 1 molecule you substitute. Then for Avogadro number of molecules you substitute. Then you derivative, take the derivative, differentiate and get Cv. Then from Mayer's relation you find Cp, and lastly you find gamma as the ratio of Cp and Cv. This is the sequence of steps in all these molecules, whether it is mono or di or triatomic molecule. I hope you must have understood well. Fine.